Hello. Cool. Hello. All right. Let me just not monitor myself. Um, let's decrease this. It's like 17 dB. Cool. Spotify. Mm. Actually, let's not deal with that right now. Let's do that later. Actually, get into the what we're supposed to be doing today. Cool. All right. Well, welcome back. This is day 2 of my self-taught CS journey. I'm going to be continuing logic gates, just going through the theory. I forgot to mention, but I'm following this computer science. If you can, you cannot see. I'm following this GitHub repository or page, and yeah, just going to be going through the curriculum. Just for clarification, I took Intro to Computer Science and Programming. I do have some like I am not as proficient in Python as I should be, and or any specific high level or low level programming language, like C++ or C or Java, Python, C sharp. But I do have like a basic. I'm not a beginner, but I'm like I know a little bit about it. But I'm not like proficient at it at all. So yeah. So I've taken calculus already. I've taken 1 and 2. I haven't taken multivariable calculus, and yeah, I told everyone yesterday that yeah I did discrete structures, but I would like just to refresh myself again and then go through that. Yeah, here is like when we're actually dealing with like data structures and algorithms, and yeah, we're gonna be doing like just arrays and lists, and I don't know, like I think trees are a little bit further, but yeah, just like sequencing through an array and everything, and I still need some like guidance on that. So if anyone's willing to kind of like work with me on that, that'd be great. Just for clarification, I'm not a teacher. I'm not like a guru or anything in this. Like I am basically starting again from step 1, and I just do know a little bit, but I'm not a master at this at all. So if I'm open to suggestions, I'm open to some helpful tips and constructive criticism. Like that's fine, as long as it's mutual. Like just being rude is like something I'm not going to be dealing with. So yeah. Um. Hmm. All right, let's just get right into it. Sorry if the stream looks kind of clunky. Gotta work on all that. So finally got the chat up today, so that's a plus. But yeah, we're gonna be going through truth tables. I'm just gonna be reading, and I got my notepad. Actually, this chat thing is really bothering me. So, 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 hello. Cool. All right. I don't know about the music per se. This is still a little, I feel like it's too loud. It's like 16 because I feel like I'm peaking. Okay. Um. Yeah. Hmm. All right. Let's just start. Mm-hmm. Oh yeah. If I can't figure out anything, I am going to be asking chat. I will ask Gemini. Like I like utilize ChatGPT much more than I do um, Gemini or any of the other AI generated prompt type of things. So, all right, just for clarification, yes, I remember. Go through logic again. So, uh, hmm. Okay, propositional. Sorry, a proposition is a sentence that declares a fact that's either true or false. Yes, so we're going to be going through. I can write. Um, yeah, yeah. It is a cap of Iowa. 1+1 is 2. 1+1 is 3. Not preposition. Propositions is how much is this cookie? The sentence is false. Um, that's the formula rules for combining or to derive new proposition. I do want to know if like I am um, if my tags are correct. Uh, um, 1 second, guys. Just need to. Yeah, let's go in here. There we go. So, uh, hmm. That's all I can think of at the top of my head right now. Okay. All right, guys. I'm sorry about that. Oh my gosh. Okay, propositional logic consists of a set of formula rules for combining propositions in order to derive new propositions. In Python, we can use Boolean variables, typically P and Q, to represent propositions and define functions for each propositional rule. Each rule can be implemented using the Boolean operators. Yeah. Okay. So let's start with actually I should just like no, whatever. Or better yet, this doesn't block the whole damn thing. Let's start over here. Negation. Okay. So negation is a statement that is the opposite truth value. So the so if is not the case at P or P. For example, the negation of the proposition today is Friday would be it is not the case that today is Friday or more. How do you pronounce this word? Succinctly. Okay. So truth table would be P and negation of P. So it's true. So if it's not, it's false. And then if it were true, oh, sorry, if it was false, then it'd be true. Four 4.12 is a conjunction. I am a rock. And I am an island. Okay. The P and Q be propositions. The conjunction of P and Q denoted in mathematics by P, and so this means and. Ooh. So truth tables Q and P and Q. So if it's true, I am a rock and I am an island, then the statement is true. If I am an island but I'm not, then that would be false. If I am not an island but I am, then that would be false. And if I am not an island, I'm not a rock and I'm not an island, then it's not. Okay, yeah, I got it right. So hmm. Okay. Okay, so yeah, return P and Q. So it's just true. Okay. Yeah. Uh, yeah, conjunction. So I want to know. Uh, okay. Let's break down from the nested. Sorry if you guys can't see this. Okay. All right. So the nested loops are iterated through two lists, true and false, for both P and Q. The AEs represent all possible combinations of Boolean values for P and Q. Here's the outer loop. P is set to true. Then the inner loop runs completely for the value of P. When P is Q, when P equals true, Q will first be true, then false. The inner loop completes all iterations before moving back to the outer loop. After the inner loop is done, the outer loop updates P to false and then process. P equals P is true, Q is true. The conjunction function P with the parameters of P and Q function is called with P equals true and Q equals true. It returns true because true and true is true. I get the truth table. I just want to understand the process of the loops. I'm okay. So to confirm my theory, the decision making is made by the return statement within the conjunction function. The iterations in the iterations through the lists are just there. All right, let's just write that out. Yes, that's correct. The decision making in this code is determined by the return statement within the conjunction. Here's how. So the function takes two arguments, P and Q, which are both Boolean true or false. So how does the next sequence true and false work with the loop? How does it know to switch to the next sequence? The way the nested for loops handle the sequences true and false is based on how loops work in Python. So the outer loop the outer loop takes one value at a time for the list true and false. It starts with the first value true, completes all iterations of the inner loop for its value, and only then moves to the next value false. For P in is okay. So the outer loop does P, and the inner loop does Q for the first sequence. Okay, I get it, but what? So P is set to the first value is true, false, which is true. The outer loop pauses with while the inner loop starts. The inner loop starts setting Q. With P equals true, the inner loop begins its first iteration. The Q is set to the first value and true. It's true. The combination P equals true. The inner loop advances updating Q. After the first combination is processed, the inner loop moves to the next value of Q. Q is updated to the next value and true and false, which is false. The combination is true. Once the outer loop finishes iterating through all values of Q, the program goes back to the outer loop. The outer loop updates P to the next value, which is true. Understanding it. Okay, now so the outer loop. its first iteration, the inner loop picks the first value true, false, and assigns it to Q. At this point, Q is true. The body of the loop runs using Q equals true. Right. Okay. Let's try writing this out. Um, so so conjunction P Q. No. We'll skip this for now. The print P and Q in A. So then the for loop. Sorry, why am I doing that? So for P in true, false, and then for Q in true or false, we need to A is equal to the conjunction of P and Q, and then we print out P, Q, and A, yeah. returns true, which then you, so then it goes, it just finished it, it pushes it there, and then it returns that, which then becomes true, which then it, so it started here, goes up here, it finishes, and then it goes back to the next thing, which is P, print out that. And then it goes to, it goes to Q. Which then turns it false. It goes back, finishes those and prints, and then it, okay. Holy shit. I was like, bro, what the fuck? I'm like, yeah. All right. Bro, I'm like, okay. So we would, all right. Let's just go from the beginning. So we have the function conjunction with parameters of P and Q. It is just here in the scope of the program. I think it is just its own thing. So it's not declared, it's not run until obviously the for loop iterates through it. So then this just prints out the label. Oh my gosh, I need to pull that down. That prints out the label. Then it runs through. So it's a for loop, and then P is set to true, right? And then it goes to the next thing, which sets it to true, which then runs the function, which then moves it up here, and then it returns if P and Q are true, which then obviously it returns true because it's right there. And then it comes back to, obviously it goes back to where it finished, and then it prints out the stuff, and then that's how it prints. But then it goes back to Q, and this is where I'm kind of like not really understanding. How does it know to? Okay. All right. Okay. Oh, because we're still in. Oh, I get it now. Oh, okay. Bro, I spent like how many minutes? Like 20 minutes understanding this. It can't. It's still set here because it's still in this for loop. It's still in Q. So that's why when it printed out this true, it goes back here. And since Q is already set to true, that's why it's set to false, which then pushes it back to it runs the function again, and then it returns that, and then it finishes it, and then it prints it out. It goes back to Q. It changes it to true. Sorry. It doesn't change it to true. It stays as false. If this is false, then it goes back to P, and that changes it to false. That changes it to true. It runs the function again. it returns the returns the value, which is false, and then it prints. It goes back to Q. Since it turns it back to false. Now I just made myself more confused now. Okay, it made sense up until here, and then wait, why does it? Oh god. Right, yeah, right around here. So this is the printed there. No, let's just go back to here. Is true, is false. Okay, printed it. It goes here. It was set to false. Wait. Okay, so it finished. Goes back to here. It can't choose true anymore, so that's why it chooses false, which pushes it here. Okay. Prints it out. Then it's false. It has to choose. Now, yeah, that's where I'm confused now. It stays at false, but then it goes back up here. Okay, this is where I'm. So on the third sequence of, oh my god, of the logic table, like it's true, false, and false. Why doesn't the Q for loop change the false back into a true? But exits the Q loop for loop and starts the P for loop and sets P to false. This is a great question. Again, it gets to the heart of how nested. Yes, because I'm like, am I not understanding how nested loops work? Okay, so the Q loop. The Q loop for Q in true false. Okay, is responsible for iterating over the list true and false. It starts at the first value true and moves to the second value false in its sequence. Once it's gone through all the values of true and false, the inner loop exits because there's no more values left to iterate over. Oh my. Okay. I was like, what the? It can't go anymore. Yeah. So it does. It can't because it's already given true and it's already getting false. So then it goes back up to true, which was already. Oh my god. Okay. Holy shit. I was like, why am I? Why can I not understand this? Okay, let me draw this out because like I'm like, what? Okay, so the for loop. So the for p in true and false. So over here, oh no, I can't do that. So this makes p equal to true. This is already correct. So then it moves over to for q in true and false. It chooses p, it chooses q to be true. Then it runs the program, runs the function. We're still here. We're still here. It goes back here, and then the for q in true and false. It changes q to false. The program runs again, runs the function. Okay, I just made like I wrote it all weird, but I wish I could. Oh my god, I wish I could like do this way better. I get it now. Okay, I was like, this doesn't help. Cause like there's no indentation. It kind of like, or I could just do like a. I could just do a true like. So the okay. So first is, oh my gosh. The first iteration. First iteration is yeah. I could do it like that. Okay, so it chooses p is equal to true. It goes over here. It. Well, I'll just erase this. It's too big. So it goes to q for loop. It goes to q for loop. It chooses the first thing. So q. Oh my gosh. So the one. Oh my god. Oh, this is so confusing. So it chooses here. So it chooses one. This chooses. This chooses. It's the 1A and 1B. So then it chooses true. Wait. Let's move this down here. So we forgot that, yeah, let's do the, this is just the function. So a def conjunction p q. So once this does this, the for loop tells it to the A is equal to conjunction P and Q. It pushes this over here. Return P and Q, which is yeah, it's a logic thing. So if it's true, then it pushes it back. Sorry. And then you print this. Print P, Q, and A. And then we go to the second iteration, which is Q. So it's true. True's already gone, so it's false. So this is 2A. It chooses F, which then is false. It runs this again. Oh my gosh, I don't think people can see it. Okay, so it runs the conjunction again. It goes, geez. It goes back up here again. Then it prints it out again. Since now there's nothing, so this is gone. So we chose this. It goes, so sorry, this is the second iteration. The third iteration makes it go out back to the loop again. True is gone, so all that remains is F. So this is 3A. Sorry, this is part 3A. It chooses this one. Then it goes to the for loop. And then it iterates again. So F is gone, but T is there. So then Q turns to T. A does its thing, yada yada yada. And it prints. It goes. Okay, yeah. Now I'm confusing myself with my own writing, but I get it now. So then it goes here, prints out here. Q turns to false this time because T is gone, but there's still F. So, and then it does A. Yada yada yada. It prints. Yada yada yada. It goes back up here. And then it goes down here, which is the fourth iteration. Okay, bruh. I get it now. All right. Just to confirm, bro. Let's go back. All right. This is just the placeholder function. It's just here. It's not run at all. We print out the label thing because you kind of need to know if it's P, Q, and A. Then it goes to a for loop. The first outer for loop, which is P, it chooses the first one. Then it goes to the Q, and then it chooses the first one. It runs the function. You go back up at the top. You confirm the logic, like the equation, which is like if true and true. Obviously, it prints true. You go back down here. It exits the function. It goes here. Then it still stays in the inner loop because we can't get out of this until this finishes. So that this is true's gone. So then it chooses false, changes it to false, prints this out again, goes back up there, returns it, exits the function, prints it. We've go back here. There's no more choices to choose. So then it goes back to P. True is gone already, so it's false. So then now it goes to the second loop, second loop iteration. So it goes into the inner loop. This is refreshed again. So then it changes it to true, which it did. Prints it out. Does that. And then it already chose true, so then it chooses false again. It still remained to false. Goes back up here. Prints. Yeah, exits the loop, prints it. It can't go in here. This is completed. This is completed. Holy crap. I forgot how for loops work and nested for loops. Oh gosh. Okay. Get it now. Jeez. Thanks, chat. I get it now. I get it now. Loops have to complete themselves once all of the indexes of the loop, of the list, or the array, whatever, the list are gone. It goes back to the outer loop and repeats the process. Oh my gosh. Jesus. Okay, you're absolutely right. My God. I was like, I'm not getting I'm not getting this. Like, I was like, I forgot loops have to finish. They can't finish. They have, like, there is the array or the list, and it's already chosen the first thing, so it has to iterate through that. And once it's all iterated, then the for loop's done. Okay, bro. My God. Sorry, I get the truth table. I already did the truth table, but now I'm like, I just needed to understand the. Okay, let's code this out because I want to just be like, why can I not open this? All right. Let's go to coding. Let's not open this application. Why am I opening that? So. All right. So we have the definition conjunction, which takes in P and Q. We're going to return P and Q because that's the function. We print out P tab A Q. Then we do the for loop. So for P in true, oh my gosh, true, false. Do another Q in true, false. We do the conjunction. Oh, we just set A to the conjunction. Conjunction is P and Q, and then I don't like how it's on end. And then we print out P, Q, and A. Oh, it's yeah. I was like, why is it like that? Let's save that again. That's kind of nasty. Let's do it one more time. Okay, that's completely off, but we get the point. Okay, so true, 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 false, 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 true, false, false. Woo! All right. Can't. Oh. All right, let's go back to studying because that was. I was like, bro, what? It's so sad. Like, I'm like, I know this and I forgot. This is why you need to do this every day. Okay. Because you can, you could forget. All right. We keep all these notes, the whatever the mess that looks like this. Um, uh, someone comment? I can't see. Uh, oh, no one did it. Okay. Okay. Really confused. Like what? Okay, close that. All right. Oh, oh. All right, let's go back to studying. Now I get it. All right, so 4.1.3. So disjunction. Oop, disjunction. All right, she studied hard or she is extremely bright. So P and Q and P or Q and Q is sorry, is equal to Q. Sorry, what am I doing? No, that means or. Jeez. Did I do that for the other one? I did. Okay, cool. My notes are so bad. All right. Let's do this. Let's do that. All right. So she studied hard, or she's extremely bright. So if both of them are true, because you only need one to complete this statement to be true. So yeah. So if it's true, and yeah, we make that to false, then it's still true. And then since both trues are gone, so now it's false, and that false turns back into true because it reiterates the loop again, the outer loop, then that becomes true, which again, you only need one to be true. And you have false, and you have another false, which then becomes false because you need both. Yes. All right, let's try it. Let's code it. Ugh. Okay. Hopefully people can see it. Be awkward. Yeah. Def disjunction. So PQ. Why is there an expected indented block? I want to copy that thing because I don't like when it looks weird. Just so I can have a peace of mind of. Okay, so then we have the for loop, which is for P and true, false. For Q and oops, true and false. We have to make a disjunction. P Q, and then we print out P Q and A. All right. I should rename this to logic. Okay. No, whatever. Okay, so true, 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 false, true, false, true, false. Sorry, false, true, true, false, 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 true. Cool. All right. All right. Let's go back to studying. Oops. Okay. So this is 4.1.4, which is exclusive. Exclusive disjunction. Whoever's watching, welcome to the chat. Welcome to the channel. Welcome to the live stream. Yes, I'm starting. We just continued. I just did some code, kind of understand. Took me like almost like an hour or something to kind of get everything. So yeah. Clarification, I'm not a master at this. I'm not a guru at this. I don't have a degree. I'm trying to get my degree in this, but I do have some background in coding, programming. I did take some courses in the past, but never really finished through. And I took discrete structures before, but I forgot everything. So now I'm just going through it again. So, yeah. All right. But welcome. All right. So take either 2 Advil or 2 Tylenol. So it is, oops. So P and Q, and then P S Q. So based off of the prompt, take either 2 or that. So you can't take both from what I'm saying. So yeah, if you take Tylenol, Advil, and you take Tylenol, that you shouldn't be taking both. If you take Advil, but you don't take Tylenol, then that is true. And if you don't take Advil, but you take Tylenol, then that is true. And if you don't take Advil and you don't take Tylenol, then you get nothing. So, yeah. All right, let's code that. Let's code that. I forgot the syntax for this. What is the is it a what is XOR in Python syntax? Huh? Okay. All right. So this is def exclusive disjunction. I cannot remember. Yes, correct. So, oops. I can't spell. Disjunction. And then P, Q, return. So I think it's P and not Q, or not P and Q. Oop. Actually, I want to. Why did I delete that? Wait, let's go back. Yeah, I shouldn't be. I should just be commenting things out, not. Eh. Okay. Oop. Wait, that's not. What am I doing? Jeez, that took so long. Okay. So F exclusive disjunction EQ. Why did I open bash? What? All right, so return P and not Q, or not P and Q. So I just want to copy this, so I don't want to do any of that. And then we code it. So we do a for loop. So in true, false, and so that was the outer loop, and this is the inner loop of true and false. We do A, which is exclusive disjunction, and we put P and Q, and then we print out P, Q, and A. Let's see. Right, so if you take Advil, you take Advil and you take Advil and you take Tylenol, then you shouldn't be doing that. If you take Advil but you don't take Tylenol, then that's good. If you don't take Advil and you take Tylenol, that's good. But if you don't take anything, then you get that. Cool. All right. I don't know why it keeps doing that. Cool. All right. Hopefully. All right, let's go back to studying. Jeez. Implications. All right. So this is, let me just put that down. So this equals like XOR. One or the other. but not both. And not nothing. I don't know what that means, but not nothing. All right. Implication. Ooh, so people. All right. If you get 100 on the final exam, then you earn an A in the class. So, if this, then this. So if you get an A, if you get 100 on the final exam, then yeah, then you get an A. If you get 100 on the final exam, okay. So from the list itself. So if we iterate through P, then we got true, because this is the outer loop. This is the inner loop. It's already gotten true. It stays here because it's still in the inner loop. We already took true, so then we do false, which then would be false. Now we go out of the inner loop because the inner loop has it's been completed. So then we go to the inner loop, and we already chose true, so then we choose false. We start the inner loop again, which resets the clock again, so it goes back to true, which then it becomes true because you only need one. This just needs to be right. If P is not true, then Q can be any value. Right. Okay. So, Wait. Does implication? Wait. Let me formulate what I'm going to say. Can you, bruh? Does if then statements are if and if then statements similar to this is so bad. I can't. But yeah, similar to choosing one or the other. I don't even know what that means. So does P, oh my god, having a true value for either P or Q make the implication true. Okay, this hopefully chat can. Yes, if then statements, also called implication in logic, involve choosing between conditions, and their truth value depends on the logic you're using. Let me explain in detail. So, if P then Q. So like I said before, but this, if P is true, then Q must also be true for the entire implication to be true. If P is false, the implication is always true, regardless of Q. This might feel counterintuitive, yes, but in logic, a statement with a false premise cannot be disproven. Huh? Bro, I'm not break braining right now. What does that mean? Wait. It might feel counterintuitive, but in logic, a statement with a false premise can't be disproven. I guess depending on the type of logic, like the type of field we're in, I guess. Yeah, anyway. Okay. Yeah, I get it from the logic perspective. Like I get this. But yeah. Hmm. Yeah. Okay. All right. Okay. Yeah. Okay. Yeah. 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 Okay. Right. So, geez. So, true, true, true. None. True, true, true. Uh, wait, fuck. Um, what? Oh, we're gonna have to come back to this because like I'm not really sorry. From try to complete the code below by clicking edit and replacing fix me once correctly define the correct truth table for implication interpret. Okay, so um, if mm, P or Q, let's see. Right. Okay, and then let's just right. Oh, you guys can't. Oh, if people see. Oh, again, I can't really tell if people are watching or not. This YouTube live thing is not really that. It says views, so I can't really tell. But concurrent viewer. Well, anyway, welcome to the chat. Um, welcome to the channel. Jesus. Um, yeah. So false, true, still true, but false, false, false. It's not right. So yeah. So true, 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 false. Ooh, no, that's not right then. Ooh, that's not right. How would you program an implication function to to explain the implication truth table. Oh, could you in Python? Okay. Not P. Okay. All right. So it's not P or Q. Right. So it would be not P. Could you explain not P or Q? I forgot to do implication. You can't read that shit at all. Uh, yeah, so P, Q, P is therefore to Q. Let's move this out of the way. So not, yeah, that'll be true. And if it's, no, what am I doing? Yeah, it's not right. Yeah, and then false, false equals false. But I'm trying to, so oops. That, okay, yeah, let's do that. Because I'm like, kind of getting confused. All right. So P, Q, um, not P, and then not P or Q, and then P therefore Q. Uh, so if it's true and it's true, not P would be false, and then not P, which is false or true, would be true because it's still right. So then it would be, therefore, it would be true. If it was true, false, not P would be false, and then not P or not P or that would be false, false, which then would be, it can't be both false. So then it would be false, right? And then if this is false and this is true, not P would be true. True or true is still true, right? So then that would be true. Then that would be false and false. That would be true. True or false still would be true. True. Woo! Got it. Damn. Oh, okay. Let's code that. Um, what am I doing? That's not what I want to do. So def implication PQ return not P or Q. For P in true, false. For Q in true. So A equals implication PQ. Prints PQ and A. True, false. True, false, true, true. Yeah. Cool. All right, let's move on. All right, converse and counterpositive in an inverse of a thing. So converse, counterpositive, and inverse of implication. All right. So converse would be P not P equals Q. Oh no. Oh, sorry. That's just the opposite. Q. The contrapositive would be not Q equals not P, right? And then the inverse of that would be not P, not Q. Yeah. Oh, okay. Uh, mm. All right, let's do the truth table. So P, Q, Q, P. Oh, sorry, we gotta start with P. Yeah, you're right. So P, Q, Q, P, negative Q. Yeah, I should do it that way. And then negative P, Q. All right. So true, true would be true. Would be true. Not would be true, right? Yeah. And then, yeah, that'd be true. Oh, yeah, I can't see that. Okay. Oh, take that one back. So if it's true and false, not P, not P, not P would be my god, why am I like blinking out? So P for true, which is true, right? Right. Okay. I was like, bro, what? Oh no, no, no. Yeah, you're right. So it would be false, which would also. Ooh, no, this is a little different. Okay, let me back up because I need like. Because implication is needed. Mm, yeah, I want to know how to like do that. So yeah, not P. Sorry, could do the same thing. So not P to not Q. So not P is not P is P. Right. 'Cause a negative and a negative equals a positive. So or positive or negative, which is basically, yeah. So not P or not Q. So that's negative and a negative just is a positive, or just a negative, which is the same thing. So then what's the converse of? So implication is, gosh. Mm. Sorry, I didn't really write that out. If the ground is not wet, then it does not rain. It does not rain. Either the ground is wet or it does not rain. If it rains, then the ground is wet. Either it does not rain or the ground. Either it does not rain or the ground is wet. If it rains, then the ground is wet. If the ground is wet, then it rains. Either the ground is not wet or it rains. If the ground is not wet, then it does not rain. Either the ground is wet or it does not rain. It does not rain, therefore the ground is not wet. Versus either it rains or the ground is not wet. Wow. Jesus. They so okay. Okay. Translate the statement: if an integer n is divisible by 4, then it's divisible by 2 using if it okay, so let's go up. Translate the statement: if an integer n is divisible by 4, then it is divisible by 2. So it's p, therefore it's q. Form its converse. So that's a, I think. And then b, so its converse. Its converse would be q, therefore p, and then translate it. If an integer n is divisible, let's move this over here. It's too much writing. If an integer n is divisible by 2, then it is divisible by 4. So it is not p, not q, not p, which basically translates into, so not q, which is a positive, or a negative p, which would turn out to being positive. So if an integer n is, if the integer is divisible by 2, then it is not divisible by 4. Ooh, you can't see. And C, its inverse, which then is P, not P, therefore is not Q, which is not P would be P, so which is positive, or negative, which is not Q. So if an integer n is divisible by 4. All right, what am I doing? Then it is not divisible by 2. Okay, let's get it if I got it right. So converse is if integer n is divisible by 2, then it is divisible by 4. I got that right. If an integer n is divisible, sorry. Yeah, why didn't I put that? Yeah. Huh? I'm stupid. Yeah. If it is not divisible by 2, then it's not divisible by 4. And if an integer is not divisible by 4, then it's not divisible by 2. I don't know why I was getting caught off on if the integer is divisible by 4 and the integer is divisible by 2, then it's true. If the integer is divisible by I'm getting lost. If the integer is divisible by 2, then it is divisible by 4. If the integer is not divisible by 4, then it's not divisible by divisible by 2, then it's not divisible by 4. And if the integer is not divisible by 4, then it's not divisible by 2. True. If the integer is divisible by I'm confused now. Let's code this out then. Yeah. So I'm just like, why am I not getting this? Oh. Chair. Okay. Excuse want to know. Okay. Mm-hmm. I want to code this out. Oop, boop. So we did identification, so let's do converse. So P and Q. Return. Oh my gosh. What am I doing? Yeah. So application is not Q or P. Just copy this. We do converse. Let's see. Let's run it. So it's true, true, true. True, 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 false, true. True, 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 false, true. Okay. All right. Oops. Oh, bruh. That was not helpful. Okay. And then, what are we doing? Hey. Okay. So def contrapositive P and Q. Wait, what? Jesus, my brain is not working right now. So return contrapositive is not Q or not P. Oh wait, no. Contrapositive is not Q, therefore not P. Am I tripping or? Uh, yeah. Okay. So let's copy this. False, true, true, true. False, true, true, true. It's not. It's not right. Yeah, because I was like, that doesn't make sense. So, but if we were to break that down, that's not. So, not Q. Not Q. Not Q. Or not P. Let's try it. Yeah. True, false, true, true. True, false, true, true. True, false, true, true. Okay. Yeah, bruh. Take me a little break after this. My brain is like finito. Okay, let's go do one more. Def inverse. PQ. Return. So let's do the thing. So it's not P, therefore not Q. But if we were to break it down, then it's not P or not Q. Okay. Inverse. Let's run it. True, true, false, true. True, true, false, true. True, true, false, true. Nice. Okay. Cool, cool. Whew. All right. Let me take a break. It's like I've been doing this for the past almost 2 hours and 30 minutes. So I should actually take a break, not like just talk about it. Okay. I'm still getting like caught up on like the 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 what does chat call it? Logical no. Jesus. What is it called? Logical equivalence. I need to like look this up because like logical equivalence. Oh, okay. This website is weird. Okay. I just need to like I should be showing this actually. Um yeah, what the fuck? I don't even know. My brain. Just look up choose table types. Because yeah, truth tables are basically booleans. So, because yeah, they give out zeros and ones. So, um, yeah, if you have zero, then you get an output zero. If you get one, you get one. And if you uh, not, I forgot what not is the opposite of this. So if this is zero, oh yeah, if you get zero, you get an output of zero. If you get a one, you get an output of one. If you get zero, then you get a one. But if you get a one, you get a zero. All right. So then and is if you get zero, not true, not true, you get would be would true be, yeah, true's true's one and false is zero. So false false equals false. Um true false equals still false. Uh, false true equals still false. Yeah. Hmm. Oh, my brain is tired. Okay. Hmm. Yeah, let's take a break. What should I do for my break? Uh, um, I would play TFT. Uh, should I play TFT? Mm, I'll play Pokemon. I'm not like really, really on my phone. Cool. If anyone's playing Pokemon, that'd be kind of cool. I just got back into Pokemon. Hmm. Also, I should check on like the actual stream itself. Like, I should be putting my videos up and posting them on my video channel. Uh, I'll do that after. Let's not have any Pokemon. This is my 4-star Gabite. So I think where we're great buddies. We're not ultra best buddies yet, but no raids, no nothing. I should also get water. Been I should put a be right back sign. Yeah, I should do that. Oop, let's not do that right now. Um, how do you do that? How do you like make the source like stay there? What does that mean? How I can't really tell. Hmm. We'll see. Let's try. Uh, mm, mm, wait, I should keep forgetting what I'm supposed to be doing. Jeez. Mm, mm. So if I do that, okay, so I can. Mm, be right back. Okay. So, oh, all right, cool. Um, I don't know who is currently watching right now, but appreciate people in the chat, in the stream. Why is this not doing anything? What does moderation activity mean? Participants. Yeah, let's just keep on live chat. Yeah. Yeah. Oh, so if you are new to the channel or you are watching currently, yeah, I am starting my self-taught CS degree journey, and today I've just went over some logic gates. Let's go over through my coding. So yeah, just doing a lot of truth gates, logic gates. So this kind of got stumped right here with my what's it called again? My nested loops. I was like, what the hell is going on? But I finally figured it out, and then it's been smooth sailing from there. Yeah, just doing a lot of stuff. If you guys would want to watch that, you can. Yeah, I feel like just take a little mini break, and then we're going to continue. By implications, start with there, and then we will go to compound propositions. Almost there. Just getting through all of this. And then after that, yeah, where should I stop? Yeah, probably right here. Yeah, like what the thing said. Like, oh my gosh. Yeah, just doing propositional logic, and then doing proposition equivalences, and then doing that. This is quite tough, I will have to admit. So, and we could start tomorrow on these. Jeez. Yep. Set theory. Holy shit. Flipped in a set. I feel like I had more affinity towards sets than I did with the lot. I think logic is kind of complicated for everyone. Well, that's just my subjective opinion, but yeah, it's a lot, but we'll get through it. Functions. Go through all of this. I want to do notes after, like just what I learned today, because that would help a lot. Graph theory, Jesus. We have number theory, graph theory. I remember graph theory, and I vaguely remember number theory, but yeah. Um, I am going to be right back, get some water, probably go to the bathroom, and continue. Hello. Does it still record? Welcome back. Um, Kind of cold. The audio stream current bit is lower than the recommended bit rate. We recommend that you use an audio stream. Okay. All right. Got some water. Kind of cold. It's a little nippy. And we're going to get right back into it. Mm, mm. Okay. Like, why does it always look like that? Let's fix this. I think we can, or we could just stop theory. We could just go back to doing some like refresher on Python. Yeah, let's just do that. Still have 1 more hour. Maybe after like 30 minutes, I can just play, a game or something like that, like TFT. Let's check. I am not currently in the know of the meta, but this is my favorite game at the moment. One of my favorite games at the moment. So. Excuse me. You can play Wild Rift on the PC. Huh? Didn't know that. Oops. I still want the skin. Oh, we could open a thing. Games. Actually, no. Maybe not. It's not for that. Just want to. Jesus, these are a lot with the 1820 RP. Basically, like $15, 15, $16. Jeez. When I used to play this game all the time. I still want this skin. I want all of these skins actually. They're kind of cool. We'll see. Anyway, I'm here for TFT. Freaking love this game. So much fun. All right, we're going to close this. All right. Or we could just go into algorithms, like just for shits and giggles. An algorithm is a step-by-step process defined by sets of instructions to be executed sequentially to achieve a specific task, producing a determined output. Examples of common discrete mathematics algorithms include search algorithms to search for an item in the data set or data structure like a tree, sorting algorithms to sort items in a specific order, insertion and deletion algorithms to insert or delete item in a data structure such as a tree or list, division algorithms such as a procedure for dividing two integers, or the Euclidean algorithm to determine the greatest common divisor between two integers, optimization algorithms such as finding the line of best fit of set of points, or problem of finding the nearest neighbor in a set of points to a given point. Here close could mean, okay. How the algorithms we describe are implemented in the Python programming language. We also provide an overview of pseudocode syntax here. Pseudocode is used to provide, okay, I know this. Yeah. We went through all of this. Yeah. Examples of algorithms. We need to proceed to develop some algorithms, beginning with algorithms for common mathematical operations. Much of the mathematical notation can be considered pseudocode. Consider the sum of A1 plus A2. So it's my gosh, this is gosh, I forgot this in calculus. Basically, yeah, this is a sum loop. This is a loop, and it's I is 1, and then n is like how many you're going to, and then, yeah. So I is equal to 1, and I equals n. So the Python code below uses a for loop to implement sum notation, adding the first n terms of a sequence A equals. So sum is equals to 0 for I in range of 0 and n. Sum is equal to sum plus ai. So return sum. So sum notation is so we're going to iterate through this array I. So it goes into the index of 1, 4, 9, 16, and then n is sum of the first 3 numbers. So, all right, yeah. So we're in index 0, which is 1, and we get n, which is 3. We go through the for loop. So we start at iterate. We iterate at 0, so 0 index. We go through it. We go through index 0, which has the value of 1. We will take the sum, which is 0, and we will add itself. We'll add 0 to whatever index 0 was, which was 1. So then, and then we do it again. We will go to index 1, which was 4. So then 4 plus 1 equals 5. And then we go to index 2, which is index of 9, the value of 9. And then we add that, so that equals 14. And then we return the sum, which is 14. And then print the first 3 numbers, which is sum of the first 3 numbers is 14. Yeah. Let's try it. Okay. This. What did they call it? Some notation. Yeah. It takes the parameters of a and n, and we start off with sum is equal to 0, which is a local scope within the function. Let's actually notate it. So sum notation, and then we create a list of 1. What were the numbers again? Yeah, these. And we stop at index 3. S equals that. And then we are going to print out, just print out what they said, which is the sum of this. And S, which is, we stored the value of the function in here. All right. So we are going to iterate through this loop. So for I in range of 0 to 3, so to n, we're going to take, we're going to take sum, or we're going to take sum plus a index of that. And then we are going to return the sum. Right. All right. Let's see what we're doing. sum of the first three numbers is 14. Right. So uh, array and an integer. Uh, set free to define as a variable called sum. Set its value to 0. Create a for loop which iterates through the array starting at 0 and ending at n. Every time the loop iterates over the index of an array, take the value of that index and add it to sum. Iterate over an index of an array over each index. Return sum. Call So define bubble sort. There's the function bubble sort. There is an array which calls the bubble sort function. This is the array, and then print out the array, the sorted array. So the program starts here, then it's called here. So n equals the length of a, which is the length of this array, which is 0, 1, 1, 2, 3, 4, 5, 6. There's 6 indexes. Sorry, 0, 1, 2, 3, 4, 5. There's 5. So for loop through the range of 0. So loop through the array, start at 0 and end at the length of the array. So we go through the range. We go through the first iteration of 6. Then we loop through it again, and we go to the first one, which is 6. We take n, which is 6, 5, minus I, which is 0, minus 1. If aj, if the inner loop of a, of the inner loop of the array is greater than the array's index, then we'll create a temporary variable, store that in there, take this an array of the index of within the inner loop, and then equal it to that, and equal that to the temp, which would return a. Okay, let's see how that goes. So, sorry, it was 6. So 1, 2, 3, 4, 5, 6. Yeah, sorry, but I was starting with the index. So start with, it just did this. Starts at 0. J starts at 0. If array 0, if array 0, which is 6, is greater than a 0 plus 1, so 6 is greater than, let's go back here. Then let temp equal 6, which it is, and then take aj, the array of index of j, which is 0, and then equal it to 1. 6 will equal, so 7. Oh, we're taking the temporary thing. We put it 6. We make this. We hold the temp as 6. This new index holds the index of j, which is 0 plus 1, so it goes to index 1. And then take that and equal it to the temp. Nice. So you took 6. You stored it into a different variable. You equaled it to 2 because it's in this one, the value of it, and then you swapped it. You do it again. You go to the index of that. Because we never leave this index. Yeah, we never leave that. And then we go again. Jeez, why did I do that? Oh gosh, you guys weren't even seeing this. Oh, jeez. My bad. So yeah, it goes to, so it's 2. Now it's 6. It goes to the index 1. It stores the value of 6 in there, copies this, swaps it, does it again, takes 3, swaps it, swaps it, takes this, swaps it, takes that, swaps it, takes 1, puts it, stores it, swaps it. Now it goes back to 0. It iterates. I see. Yeah. Nothing is higher than that, so that's why it doesn't swap. Goes to index 2. And it swaps it back. Swaps that back. You got the, geez. Let's try it. So we'll sort. We put bubble sort, equal it to, how many numbers were there? 6. All right. Print. What was it? Just print out the array. Okay, it takes an A, which is an array. So we go through the loop. The length of A, right? Oh, yeah, you could just put it in there. N equals the length of A, so N is here, or J in range of 0 minus I minus 1. That's crazy. I need to understand. Right? You return A. Jeez. Wow. Can't see what I'm looking at. Hmm. So there is lectures. I can watch this. Let's do that. Just finish these. We can do these tomorrow. Okay. Negations. Hmm. I could also just look at the discrete book. Yeah. Hmm. Yeah, I could just do the homework in here. But we're not there yet. Yeah. Jeez. Yeah, this is everything. Yeah, let's read that when we're done. I could do the homework here. Yeah. Okay. Also should be taking notes as well. So yeah, this is day 2 of a self-taught CS journey, and I am kind of tired. Like, I just need to get through all this homework. Like, truly understand what's going on. I do. So yeah, we have just normal equations. So just normal propositions. Having a negation, conjunction, to the for loop of all that, and kind of understood the nested for loop, disjunction, exclusive disjunction, implication. I could reverse contrapositive and inverse of these implications. Ooh, I will be right back. I have a call. Hello. Cool. All right. I am back. Turn off this monitoring output. Okay. Um. So yeah. Um. Do believe I have a viewer right now. Welcome to the channel. Um. Yes. It is day 2 of my self-taught CS journey. I am currently going through discrete structures, specifically like the logic gates and stuff like that. And if you would want to go to the end and or the beginning and kind of look through all that, like me struggling through everything would be good. Yeah, that's yeah. I've been doing this for I think like almost 3 hours. Will be 4. Did have to take a break there and then had a call. So yeah. Um, I think the next tomorrow, the plan is to just continue discrete structures, kind of finish half of the other part of the logic gates, like De Morgan's law and all those other things. Um, hmm. I'm I want to start coding a little bit more, but the theory is really helping. I'm kind of like breaking down like concepts that I like forgot about, and it's helping me. And I think I need to read more. Like probably off stream, I will be reading and kind of like just getting through a lot of like the heavy hitter type of concepts, and then when I'm on stream, I probably will just work on like problems and stuff like that. Um, yeah, I am enjoying myself. Got a lot of stuff done today. I learned a lot, and I will be here tomorrow and the next and the next. And this is kind of like what I want to do. And hopefully by then we're starting to create a channel. If you are new here, I'd appreciate just leaving a like, or informing your friends or stuff like that. Like the regular schmegular like mumbo jumbo that YouTubers say, like it does help. Um, and if you are one of my past subscribers, and the content is not the same as in which I did before, like 5 years ago, like reactionary, content. Yeah, I have drifted towards this, and this is kind of like what I want to do now, and yeah, and I have nothing else to say. I really enjoyed, learning today, and I hope everyone who does watch and stays and learns something. We can struggle together, and yeah. Oh, so yeah, quickly just went through the propositional logic gates. We learned about like what are they called again? And or XOR, like converse, contrapositive, inverse. We went over some like algorithms. Uh, did bubble sort. Did summation, like array, thing, and yeah. Um, Trying to think. I'm still figuring out like the schedule. It's kind of for the past 2 days. It's been around like you know either 9 or 10. I can't really remember when I started, but yeah, it is. I feel like I should make a more consistent schedule, and you know, so people can like be aware, even though most people are just coming in and seeing and then leaving. But it'd be nice to have just like a consistent like schedule that is posted, so that people could that do want to come back or do like or who do want to subscribe can do so. So I should do that. Also, I should learn more about the YouTube stuff, like just scenes and music, because like the stream had no music this time. I didn't want to get like a copyright like mark on my channel. Um, yeah, there's so much to do. A lot of time just staying consistent and moving forward and being present. It's important. Anyway, thank you for everyone who did watch the stream, and I will be seeing y'all later.